7.7, calculating equilibrium concentrations. So again, highlighters and colored writing tools would be handy for this. I don't remember how many, so we're gonna see how many we'll need. Okay, so honestly, we did this section already pretty much. So the math that I was showing in previous sections is pretty much what we're gonna be doing. And so this is probably, out of all the sections of this unit, the most important, as I said here. It's the math. It's the rice tables that we went over. It's the perfect squares that I went over in a previous section. It's the quadratic formula. So, know those well. And as a reminder, like I said here, K is products over reactants, so make sure you can use that. And then here's an example we're going to talk about. K being super duper small. Okay? So, what if K is very tiny? And so, if K is tiny, we might be able to use a shortcut. Now, I'm going to put rule in, quotes, because it's not a real rule. And honestly, you don't have to use this shortcut, but it saves you so much time on the math. So, I recommend it. So what the heck is this shortcut? We have 100 times K, so K being the equilibrium constant, is less than the initial concentrations of R. So if there's multiple reactants, then we're looking at all of them, not just one of them. Every single reactant has to follow the shortcut in order to do it. So if K is very small compared to the initial reactants, then I can think about where I have a lot of reactant, barely any product, because it's a reminder, the ratio, P divided by R. So if I have a small K, that means I have a lot of reactant, barely any product, okay? And so that means this is very reactant favored. So I'm going to, ignore the variable in our rice tables if it was not initially at 0. Very key part of this shortcut. You can only ignore the variable if it's not initially at 0. And what I mean by that is, in the problem, you know how some things are given and some things are starting at 0. So if you're not starting at 0, then okay. So be very careful about ignoring X. Be careful. If it starts at 0, X is very important because a value is more important than a 0. That's like super important, right? So be very careful about that. Okay, so here's an example problem. Let's do a quick mini your turn. Fill out that rice table, y'all. So read the problem, fill out the rice table, pause the video. Okay, ready for that rice table? You ready? Here it is. I squished it because of notes, And so let's talk about the things that I put on here, just in case you're like, where'd these values come from? And so suppose a sample of air has that and that before any reaction occurs. So since it's before, it's the initial. So I have my initial N2, my initial O2. Cool. It did not mention NO, so we're going to assume it's starting at nothing. And so because we have some of this and we have none of this, automatically this side is going to be positive, this side is going to be negative. That's why these are subtracting. This is addition. Now, I do realize that a lot of the practice problems we've done so far always are subtracting reactants to make products. That is not always the case. It always depends on what's initially given in the problem. If I had no reactants, then obviously we're going to shift and make some reactants, and so these would be additions. So be very, very careful on which plus and which is minus. So then I do my E based off the I and the C, so I just take that value minus X, that value minus X, and then 0 plus 2X is just 2, or 2X, and so that is my rice table. All right, so let's test the shortcut. Can I do it? So again, the shortcut is Kc times 100 equals that. So this is the value. So going back to the shortcut real quick, 100 times K, right? And so the K is Kc in this example. And so that's that value. And so I'm going to compare it to the shortcut, right? And so 0.001 is going on this side. And then I look at my reactants. So I can see my value in the shortcut on the left-hand side is indeed less than the initial concentrations of these two. And so because they're true, I can do the shortcut. So any amount of this is negligible. Now, again, let's think about why, because the why is the important part of why this shortcut works. So let's go back to this slide here. So again, we are going to have a lot of reactant. A tiny bit is going to become product. A tiny, tiny bit. And so how much bit is it? Barely anything. And so when you're filling out and doing the math for this, we can ignore the x values for these two because barely any of them are going to touch. You'll see what I mean in a second. So we can ignore the x, the variable x, here and here on the reactant side for this problem. Okay, so we're going to say it's quote-unquote constant. It's not, because it's like a tiny, tiny bit is being used up to make the nitrogen monoxide, but it's such a small amount. You'll see what I mean. And so because it's so small, I'm going to rough estimate that this is 0.08, this is 0.02, and then this is 2x, okay? Again, that's how the shortcut works, is I'm ignoring this. But remember, if you started out at 0, you do not ignore x. That is an important amount because 0 versus an amount is important. And so I'm putting my Kc based off the balanced reaction, products over reactants, and then I was given this value earlier right here. So Kc equals 1.0 times 10 to the negative 5. And so I'm going to go ahead and plug in my values. Now, if you notice, the math is significantly easier because I'm just multiplying two numbers together rather than 0.08 minus x times 0.02 minus x. That would be more math quadratic formula. Disgusting. And so we can do the shortcut instead. And so I'm going to go ahead. Again, I have my products. I am plugging in based off the E part of the rice table. I have my value of Kc right here. I am going to do math. Algebra, you know, be able to do it. And so I got my x. And so now that I have my x value, I can give the equilibrium concentrations of the reactants and products. So the N2 and O2 is still approximately these values because, again, we shortcutted it. And then the NO, I'm just plugging in the x, and then I multiply that by 2, and I have a value. And so the thing that I said earlier where there's barely any products versus reactants, that's very true. Because if I look at the concentration here of NO, it's 10 to the negative 4. That is significantly smaller than 0.08 and 0.02 because that's, you know, a factor of 10 squared. So that's a lot. So that's why we can ignore these versus not ignore this one. Okay? Now, I'm going to show why this x is negligible. Okay? So here's the thing again, right? So here's the x if I were to actually calculate it, okay? Or was I given earlier? Oh, no, that was given earlier. Okay, whatever. So here's an x. I was too lazy to do quadratic. I just used the x as last problem. But, you know, if I solve for x, it's like almost the same thing. Anyway, let's find the equilibrium values using this x, right? Because it's 10 to the negative 5. And I wrote it down long ways for a reason. So you can see here, I'm putting all the zeros just so it's easier to do the math. If you look, it's going to be 0.07, blah, 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 blah. So close to 0.08. Oh, I didn't align that. Oh, that's going to bother me. Because it's not aligned based off the decimal. Oh, well. Anyway, you know, doing the subtraction, it's still going to round to 0.08. I do the same thing for O2. It's still going to round to approximately 0.02 because it's going to be 0.0199, whatever the math is. And so that's why this minus x could be negligible. And so that's why we take it. Now, again, repeating. Why am I repeating? Extremely important. So this NO equaling 1.3 times 10 to the negative 4, that's significant because the initial was nothing. And so do not ignore something when it has starting at nothing. Okay? Cool. Common mistakes. Making all the x's 0. So going back here, making this nothing. That's a very common mistake people do. So the products are important for this. The reactant is estimated in the example from earlier. So we did these two as estimation, and then this one mattered. Sometimes students just check the shortcut for one of the reactants and it works, and then it doesn't work for another reactant. It has to use all the reactants, follow the shortcut. So you cannot do this if the shortcut doesn't work. If the shortcut doesn't work, then you have to do quadratic sometimes, or perfect squares, or regular algebra, depending on what it is. So be very, very careful. Now, do you even have to do the shortcut? No. Math works fine. It's just algebra, or algebra 2. I don't know. All the maths blend together after a while. Cool. And so, if you notice, this section didn't have a your turn, like a true your turn, like I usually do. And that's because we're going to do practice problems from a worksheet. So, we'll do that in the future. I don't know what day yet, but someday. Okay, bye.